Welcome to DevLog 9 for my game Gradient, a third-person mini Metroidvania. I've developed a wave spawn system that can be triggered either by Hugh entering a volume or interacting with an object like a terminal. I've used one of Unreal's file types called data table. Here, each row represents a new wave, so there are 5 waves in total for this example.
The waves.
For each wave, I can set the number of each specific enemy type and the max number of enemies that can be spawned at one time. I followed one of Ryan Laley's YouTube tutorials to get the basics of the system working. I made some significant changes since my enemies aren't the same asset type that he covered, but at this point I have it built out so as I create new environments or add new enemy types, I can simply add them to the data table, then drag and drop. I can have it pull different data tables based on a number of factors, like how far Hugh's progressed through the story, what abilities he's unlocked, or even if you're doubling back through an environment, so you won't always have the same enemy composition, just to add some variety. Another way I've added variety is by the addition of a new shield component for enemies. If the enemies survive for a certain amount of time, they can deploy a shield. The shield is damageable by any weapon, but if Hugh uses an attack of the same color as the shield, it does significantly more damage.
Destroying the shield!
But if you stop dealing damage, the shield can regenerate. It's built in a way that the enemy shield always starts on a color Hugh has unlocked, but is not currently playing as. This forces the player to have to switch colors to be more effective when taking out these enemies. The story reason why the enemies are able to deploy a shield is the longer they survive, the more they're able to learn and adapt to Hugh.
They're evolving.
I've always found it frustrating in games that send waves of enemies at you. The hardest part of the fight is just right at the start. Each enemy you kill decreases the challenge. So with this system, you should try to take out enemies as quickly as possible before they get stronger, so as the fight progresses, there may be fewer enemies, but the enemies that remain are able to adapt and become a greater threat. I have more enemy mechanics with this same thought process in mind, and I'm excited to get them built out and share. And if you like this idea, please do all the YouTube stuff, like, subscribe, hit the bell, comment. And if you're not sure what to comment, I'd really like to hear what color you're most excited to play as. Maybe I can entice you to say it's green since I've added a new charm, Sticky Bombs.
The bomb that sticks, a sticky bomb.
When you aim down sights with this charm, you can shoot up to 6 projectiles that stick to surfaces or even enemies. When you hit fire, all deployed sticky bombs detonate simultaneously. It ends up being a really creative tool since you can stick 6 different enemies, detonating them all at the same time, or even better yet, stick 6 bombs on one enemy and lead them into a pack, detonating them all at the same time.
That's a lot of damage.
Getting the projectiles to work as I wanted was pretty easy since I already have grenades working for Yellow's AoE. So I was basically able just to lift them over and make some slight changes so that they only detonate when hip firing. But I had a much harder time getting them to actually stick to the enemy models and move like you'd expect a sticky grenade to work.
Come on, work.
There are dozens of Unreal tutorials on YouTube how to make sticky grenades, but they're all just talking about sticking to static surfaces and not moving with an animated character. So, just to share how I was able to get this working, from inside the projectile I have 3 components. The sphere collision is the root, which allows me to get information on what objects versus enemies it's hitting. The mesh, which is the only actual visible part in the game right now. I have it set to a glowing donut right now just for our demonstration purposes, so I can better track the position and the rotation to see that it's updating correctly as it's attached to the enemy. Finally, I have the projectile movement. This piece allows you to set things like the initial velocity of the projectile or how much gravity affects it. Since projectiles stick to targets and only deal damage once it explodes, I first need to figure out when the projectile hits an enemy versus anything else. I also need to see where on the enemy it hits so I can get the position and rotation of the limb so that it actually looks like it's stuck onto the enemy. So here in Blueprints, once the collision sphere hits anything, I check to see what that thing is. I have a tag on all my enemies named enemy, so I check if the object hit has that tag. And if it's not an enemy, I don't do anything. So it just goes out this false pin doing nothing. If it is an enemy, then I take the other component here, which I know is an enemy since it passed the previous check, and I store it as a reference for later. This next bit is what took me longer than I'd care to say. What I ended up doing is getting the bounds of the projectile's mesh. Here as an example is the bounds of Hugh's mesh. It's just a box that updates to enclose all of the mesh at a time. You can see it here as well on the projectile as the green box around the mesh. For this demonstration, I'm showing the component bound because this is set to world space and you can actually see it, where in the blueprints you need to be sure that it is the local bounds. So since we have the bounds of the projectile mesh, we next need to get the world location and the forward vector to know what way the projectile is pointing. Then we just do a little math. This all allows us to shoot a line trace component out of the projectile. You can see that here as the blue and green line. When it hits an enemy, it returns the name of the bone on the enemy hit. So I can set the position and rotation of the projectile to that enemy bone. The target is the sphere collision since it's the default route of the projectile. We need to parent it to the target component, which is the enemy we hit, or in our case, the bone we returned from the component trace. I finally set the rotation and scale rule to keep world. If you don't keep it set to world space, the projectile will teleport off to the wrong location and it'll just look like it disappears. Now, when we shoot the projectile, you can see if you hit an enemy in the leg, arm, or head, as they run, turn, twist, the projectile sticks to them. Thanks for making it here to the end. Please consider giving the video a thumbs up and subscribe if you enjoyed.